Hello, I'm Roy Widgecombe. I'm here with Customer Manager Rami Latif, and today we're going to talk about the Cessna Skycourier with the PT6A 65SC engine.
We're going to use the airframe maintenance manual in order to show you how to optimize your rigging so that both engines work the same way. Follow me into the cockpit. I'll take you through the engine control system. This aircraft uses the standard PT6A quadrant layout with separate power levers, propeller levers, and condition levers. The power lever sets the engine gas generator speed in both forward and reverse modes. The propeller lever unfeathers the propeller and sets the propeller speed for minimum governing to maximum operating speed. The condition lever commands fuel on and off and sets both ground idle speed and high idle speed. In this application, high idle is labeled cold start. This position provides an enriched fuel schedule for cold day starting. Now that we've seen the cockpit, let's take a look at the engine controls. Let's take a look at the propeller governor. The propeller governor has three connections: the speed select and feathering lever, referred in the AMM as the governor arm, the governor reset lever, and the beta valve via the beta lever. The beta valve is set halfway along the beta valve chamfer. This position is referred to as the null position. It is set by adjusting the reversing cable front rod and clevis. Setting the beta valve correctly provides the correct propeller fine pitch blade angle. Setting the beta valve too far out may result in issues unfeathering the propeller or in a slow response of the propeller. The governor NF link gap should be measured and adjusted to be 0.1 inch or 2.54 millimeters. This setting defines the point the governor reset lever begins to reset the governor pneumatic overspeed protection to a lower speed for reverse prop operation. To make this connection, place the propeller lever fully forward and apply the friction lock. It is required that the governor arm levers on both engines be installed at the same angle, otherwise a split in the cockpit levers will result when the propellers are set at reduced speed. When connecting the rod end to the governor arm lever, make sure that the governor arm lever is placed at the maximum speed stop. Confirm that the maximum speed stop is contacted and the feather dump valve plunger is fully depressed when the cockpit lever is moved from maximum speed to the feather position. Any adjustment required should be done per the AMM. Let's take a look at the rear of the engine where the fuel control is found. This is the PT6A 65SC fuel control unit. We're going to take a look at both the power lever and the condition lever. Place the cockpit condition lever at the idle run position and apply the friction lock. At the condition lever connection, first insert a number 12 rig pin through the rigging hole in the casting and lever. Adjust the rod end to permit the bolt to be easily inserted as a sliding fit in the middle hole of the condition lever per the AMM. Remove the rig pin. Move the cockpit lever to the cutoff position and confirm that the FCU cutoff lever is on the cutoff stop and the plunger is fully depressed. Move the cockpit lever to the run position to confirm that the FCU cutoff plunger is in the fully up position. Then move the lever to the cold start position to check that the high idle stop on the FCU is contacted. Return the cockpit lever to the cutoff position. Install a 3/32 inch drill bit through the rigging plate and the Cambox lever as shown. The Cambox lever must be placed at the cam track point to do this. A simple way of obtaining this angle is by using a piece of paper folded as shown here. The input lever is installed per the AMM at 22.5 degrees below horizontal as shown. To secure the lever, the rig pin must first be removed. The cockpit PLA is placed at the idle gate and the friction lock applied. With the cam follower set at the track point, the input rod end from the power lever is adjusted to be a sliding fit with the Cambox input lever. The connection is then secured. The PLA should be moved from the idle gate to max forward to confirm full and free movement. We now install the interconnect rod. Check the rod length is 8.25 inches between centers. Install the rig pin through the Cambox plate hole and Cambox lever. Install the interconnect rod in the third hole from the top of the Cambox lever and secure. The lower end of the interconnect rod is attached to the top hole of the FCU input lever. Use the serrated washer to adjust the position of the FCU input lever so that the lever can be connected as an easy fit with the FCU body. Make sure that the rear reversing beta cable clevis is disconnected from the reversing cam when you do this check. We can check the PLA forward and reverse pickup points by placing tape along the quadrant. The idle gate position and the ground find position are marked on the tape together with the NG pickup points 1/8 of an inch forward of the idle gate and 1/8 of an inch below the ground find mark. Place the PLA at the idle gate. To find the forward and reverse pickup points, a piece of paper can be used. With the PLA in the forward position, insert the paper between the deadband screw and the cam surface. Bring the PLA back to the idle gate, gripping the paper. Now move it slowly forward, gently pulling on the paper until it releases. This is the forward pickup point. Mark this position on the quadrant tape. Now move the PLA into reverse and again insert the paper between the deadband screw and the cam surface. Move the PLA to the ground-fine position, gripping the paper. Gently pulling on the paper, slowly bring the PLA towards reverse, and when the paper releases, mark this position on the quadrant tape. This is the reverse pickup point. Finally, we can check that full travel of the PLA in both forward and reverse ranges is available, with both the forward and reverse stops on the FCU being contacted. If any adjustments to the deadband are required, the deadband width can be adjusted using the deadband screw. Turning the screw in increases deadband width. Turning the screw out decreases deadband width. The deadband position can be adjusted by changing the interconnect rod length as shown. Lengthen the rod to move the deadband forward. Shorten it to move the deadband rearwards. Make sure these settings are equal on both engines to ensure the running check will be satisfactory. Install a 3/32 inch drill bit through the rigging plate and the Cambox lever as shown. Connect the reversing cable to the reversing cam by gently pulling on the rear clevis and adjusting it to be a sliding fit with the reversing cam at the second hole from the top. We will now carry out the running checks to see how the two engines work together and make any adjustments as required. The engine starting procedure and functional checks are similar to most of the other PT6A engines. However, in cold weather, as indicated by the AMM, the condition lever can be advanced to the cold start position to assist in starting. With the oil temperature in the green and engine loads applied per the AMM, check the low idle NG speed. With the cockpit propeller lever fully forward, confirm that the propeller speed is above the minimum value in the AMM. If not, adjust the idle NG speed by releasing the clamping screw and adjusting the opposing screw as shown. Move the condition levers to the cold start position. NG will increase and should be 82 to 84% or per the AMM. If the required NG is not met, then the high idle roller should be adjusted as shown. Moving the roller out decreases NG. Moving it closer to the cam increases NG. With prop levers full forward, increase the PLA until maximum prop speed is reached. It should be between 1680 and 1700 RPM. To increase prop speed, turn the adjusting screw out. To decrease speed, turn the screw in. With prop levers fully forward, advance the PLA until prop speed reaches 1500 RPM. Compare the engine torques with the torque chart. Lengthen the beta cable to increase torque. Shortening it reduces torque. Set the PLA at idle. The propeller speed should be above 900 RPM. If the speed is below 900 RPM, the low idle NG speed must be increased until the prop speed is above 900 RPM. The power lever matching check is performed to determine if any significant knob split in the PLA exists when the engines are operating at matched torques. Check the power lever split at 50% torque and above. With this aircraft as rigged, both engines were well matched, with lever splits of 1/8 of a knob or less, so no adjustments were required. Later in this video, we will show you how to correct for split lever conditions. Reverse power should be approached with caution, with the aircraft well secured. Slowly pull the PLAs to the full reverse position. Check that the AMM minimum NG speed requirement is met. If reverse NG does not meet the requirement in the AMM, the FCU maximum reverse stop should be adjusted. Turn the screw in to increase NG and out to decrease NG. That concludes the basic rigging checks. We will now look at two conditions you may experience with PLA splits: a constant PLA split and an increasing PLA split, sometimes called a progressive split. To correct a constant lever split, the interconnect rod on the lagging PLA should be lengthened 1/2 to 1 full turn. This forces the FCU lever rearward into the deadband and requires that the PLA on the lagging engine to be increased to match the leading PLA to obtain matched torques. To correct a power lever split that increases as power is increased, the serrated washer is used. Indexing the serrated washer forward on the lagging PLA will advance the FCU arm, again forcing the arm to the rear when connecting the interconnect rod. This completes the rigging and running checks of the PT6A 65 SC engines on the Cessna Skycourier.
We would like to thank the team at Mountain Air Cargo for their assistance in making this video possible. Thank you.